talk today about progressive web apps, sometimes just called PWA on the web. And I'm going to try and talk about them from a high level. I'm not going to do any code today. I'm going to show you quite a few examples. And because it's the web, I'm going to have you try a bunch of them. So if you have a phone or a laptop or something, I would encourage you to use it in order to see what's going on here. So progressive web apps are fairly new. I don't know how many of you have even heard of them before. I mean, you're here in this talk, so there was enough in the title to get you in the room. But is it brand new for most people here? Some people. So the concept is being able to take the best of a native app on the web and combine them into one thing. And this is something that's possible because of an emerging set of web standards, especially being done by Chrome, but they have been widely implemented across various browsers. But Google has really pushed the way forward for this. So first off, I want to set the stage for some of what we're going to talk about. I want to begin with thinking about mobile in general. So this is a slide from Benedict Evans, who has a great presentation called Mobile is Eating the World. And if you haven't ever looked at his slide deck before, it's fantastic in terms of the kinds of statistics that he has. But I just wanted to look at this one as an example. So this is going to 2014. But if you're like me and you've been involved in computers for a long, long time, he shows PCs. And he looks at PCs. I don't know if you can see the scale of the numbers here, but this black line represents PCs that are sold, and we're talking about hundreds of millions of PCs. And if you think about how transformative PCs have been, this is what we're talking about here. You can see the decline. This here represents smartphones, iOS and Android phones. And you're talking here about billions of phones as opposed to millions of devices, so millions of PCs. That difference is, I think it has snuck up on a lot of us. Many of us who are in the room today, I know, think in terms of desktop machines, laptop machines, keyboard, monitor, but we really have moved into a new era. We've moved into something very different, and that is the pervasiveness of mobile and mobile apps. This I saw the other day and I loved. Why does this orange have a web browser? And this is really important. In September 2010, Wired ran a cover article that said the web is dead. And maybe you didn't know that. In 2016, it's hard to imagine the web being dead. But at that point, Wired was pretty sure the web was dead. And they've since obviously had to backtrack on that. But in 2016, the web is bigger than it's ever been. The presentation, if you were just here in the previous talk, you saw some of the kinds of innovation that people are thinking about as well as thinking about with devices and inter-device connection and so on. And just how much of the web you've used, or not even today. Your life is a mix of native apps and the web, and the mobile web is huge. It's a big part of the platform. In 2012, Mark Zuckerberg famously said that one of the biggest mistakes they had made at Facebook was betting on HTML5. They had tried to rewrite Facebook as a web app, and they had failed. The performance of the web at the time had been a disaster for them, and they had to backtrack. And so they invested a ton into iOS and Android apps. But a lot has changed in the last 4 years. So this was another interesting slide that was pulled out by DHH on Twitter from Ruby on Rails project. So he says in his blog post, "Program to where the performance puck is going to be, not where it has been." Nice Gretzky quote there. This slide here shows the performance of the Jetstream JavaScript benchmark running on a MacBook and running on the iPhone 7. And it's actually faster on the iPhone 7. So we've gotten to a point now. Apple's got a lot of criticism this week because their hardware has lagged so much, especially on their laptops. If you watched the event yesterday, you know that even what they put out yesterday isn't as fast as it really could be with the chipsets that are available. But it's really unbelievable to think that your phone is now faster, potentially, or is going to be faster than your laptop. Especially with ARM chipsets, you're seeing Moore's law just continue to go down and down and down. It really is. It's an unbelievable situation. So JavaScript performance, the performance of the web in general, has got to a place now where I don't want to make the claim, and I'm not, Mark Zuckerberg obviously has more insight into what they did there, but would it be possible to rewrite and make huge complex apps in mobile today for the mobile web today? And I think the answer is definitely yes, because we see so many of them. This is the situation we find ourselves in with apps in the App Store. Apple shipped its App Store in 2008. And it's interesting because when the first iPhone came out in 2007, there really weren't apps, and there wasn't an App Store. It's hard to remember that time now. They marketed that device heavily as having the web. So when the iPhone came out, I mean, every new platform gets its content by leveraging a previous technology, and the web is consistently, that's why that orange has a web browser in it, because everyone needs to have a web browser in order to bootstrap their new platform to have content. The problem with app stores is, it says it right here, you have top charts. If you are developing for the App Store or Google Play, and you are Facebook, or if you are YouTube, or if you are whatever, if you're Snapchat, Instagram, you're doing well, and people have installed your app. But if you're not one of those, it's very, very difficult to get seen. App stores are designed for hits, they're designed for the top 20, it's like music on the radio. It's very, very difficult for you to cut through that noise and get yourself noticed. Another great tweet. According to Netcraft, there are roughly 140,000 new websites per day. Last year we added roughly 100,000 apps. The scale of the web is unbelievably different from the scale of apps. Yes, there are a lot of apps. Tim Cook was on stage at the Apple event yesterday touting the fact that the Apple TV, the new Apple TV that they're talking about, they have 8,000 apps for Apple TV. I mean, it's sort of ridiculous to think about how small that number is, right? Obviously, Apple TV is a niche platform, etc. But if you're Apple and your app scale is 8,000 for that, so there are lots and lots of apps. But the thing is that there's a lot more websites. So I was driving near where I live and I saw this sign, so I took a picture of it. And this is Subway restaurant. Download our app. How many of you are running the Subway app? Bless your heart, not one. Okay, well, I'll go ahead and download it, and we'll take a look at it. And nobody's reaching for their phone. Oh, John's telling me this. Maybe he's going to put it on his phone. People don't install the Subway app. Why don't they install the Subway app? The top 7% of smartphone owners in the US account for almost half of all of the download activity. This is the really interesting statistic. The average American, and I would say Canadians are as average American as you can get, smartphone users download how many? 0 apps in a month. How many apps have you downloaded in October? And you're probably you're probably this group up here rather than this group down here, right? People at a technical conference, people who know what open source is, people who are thinking about their devices a lot, and you're very engaged. And people just don't download apps. Most people don't download any of these apps. People spend their time in just a handful of apps. They spend their time listening to top 40 rather than listening to the back catalog of whatever you can imagine. So Chris Anderson had a long time ago talked about this idea. You've probably heard about it. This is his drawing of it, what he calls the long tail. That increasingly, instead of just having hits, people spend most of their time in this long tail. Maybe you're interested in some niche thing that I'm not interested in, and the web enables that in a way that we don't see with apps. It's not worth my time to build an app for all different platforms, market it, put it in these app stores, go through the rigmarole. But people do it with websites. And so people still spend the majority of their time in that long tail. Yes, they use Facebook, yes, they use YouTube, and so on, but they also use all sorts of other obscure, wonderful things. And that's the power, one of the powers of the web. We've seen quite a few attempts at what I'm going to show you today. And what I'm going to show you today is one more attempt. It's not necessarily the best way, but it is yet another way we're seeing this happen. So what I'm going to call on the web versus of the web. So Adobe has tried it with Air, a technology that they did. Firefox OS tried to do it by building a phone out of HTML, CSS, and JavaScript. BlackBerry tried to do it, WebOS. Electron is another famous one right now. Lots of desktop apps that are built with web technologies. Even the Apple TV uses JavaScript for a lot of for programming its apps. But it doesn't have the web. It doesn't have some of the core things that we would think about as being integral to the web. Things like links, just having all of the platform of the web available to it. So building things with web technologies is different than building things on and for the web, is what I want to argue. So this question plagues us. And in some ways, this is an interesting question because it almost depends where you are on the generational divide. Do you think about the web as a series of documents, static websites, web pages, and so on? Or do you think about them as apps? Or do you think about all of the as being all of the above? Some of you will have grown up in a time of apps, and your world has been dominated by apps. And the generation that's coming right now, that's pretty much all they know, right? Mobile devices, these billions of devices, and running apps. For others of us, I started when the web started. I was doing all this, and it was websites and web pages and web rings and all these different things that used to exist. And so it's interesting because the web can't decide what it is. If the web was owned by a company, if the web was a product, somebody would have chosen for it already. They would have said, no, the web is documents. In fact, we would have had documents as the choice long, long ago. But when apps came along, the web seemed to be capable of doing apps. The web could morph and absorb that, and it could do apps, and now it does both of these things, and other things too. So part of what has allowed the web to survive is its elasticity. It doesn't know what it is. It's a hybrid of a lot of different things. So the things that we're going to talk about today, these progressive web apps, were first defined by this guy, Alex Russell. He's a Chrome engineer at Google, and he wrote a blog post of what he called progressive web apps. And he sat down and he was thinking about how to give name to the kinds of web pages that he was seeing evolve, like all of the things that people were doing. So I'll just read this. So part of what he says, these apps aren't packaged and deployed through stores. They're just websites. That's the first key insight. And these are websites that did something, that they took all the right vitamins. So they keep the web's ask when you need a permission model, and they add in new capabilities. He goes on and says, users don't have to make a heavyweight choice up front and don't implicitly sign up for something dangerous just by clicking on a link. The web has succeeded above all other platforms because of its installation and update mechanism. It's unique anywhere in the world in terms of how every time you go to Gmail, it's a different application that you're running. But you don't think about it in those terms, except for when it breaks, that one time when you need it. Sites that want to send you notifications or be on your home screen have to earn the right over time as you use them more and more. They progressively become apps. This is what he's saying. This is his concept. So let me take you through what are the hallmarks of these apps or this way of building for the web. The first one is that they're progressive. So you may have heard of the term progressive enhancement or progressive degradation, and it's a term that first came out in 2003, right at the height of the browser wars. And you had proprietary companies that were battling it out over control of the internet. And so somebody would introduce a feature to the web, somebody else wouldn't have it, and as a web developer, you're building something that needs to work on different browsers. And it was a terrible time because people didn't compete by implementing standards, they competed by innovating in proprietary ways. So progressive enhancement was an idea where if I give you a web page, it should work on any browser that you run it on. It may not do all of the things in all of the browsers, but you should have something. It should render text. It should be usable on some level. That was the idea behind it. And that idea is still here. The reason that progressive enhancement is still really important for what I'm going to show you is not all of the browser vendors have implemented all of the standards yet. So we're talking about a way of building that works perfectly in some areas and not in others, but should work well in all of them. So really there's been a shift. Instead of thinking about having your app degrade, they're thinking about making an app which will eventually do more, right? So for example, I'm going to talk to you today about a technology called service workers. Really popular right now, very new. And service workers is not yet implemented in Safari, but they're working on it. It's implemented in all of the rest of the browsers that you see there. So like there's an example of something, right? One of the key pieces of what we're going to talk about isn't there on iOS, and it's coming. So what do you do until it gets there? You have to deal with that fact. You have to deal with the lack of it. So these apps are progressive. The next thing is these apps are responsive. We all use the web. I haven't yet used the web on an Orange, but it makes the point. You're using it on all sorts of different devices. Some of you are on laptops right now, some of you are on tablets, some of you are on things that I don't even know what they are. Are they laptops or tablets or, like, we're in a space now where we don't know. You're on big screens, you're on televisions, you're putting the web in things like cars. And so the idea that the web looks a certain way has been eroded. The web is whatever device you're working on. So these apps need to work well in all different conditions, whether it's on a phone or on your desktop. We shouldn't be making decisions. One of the things that these apps do is they treat the network as an enhancement, which is really a bizarre thing to think about. As long as we've been doing the web, the one thing you need to do the web is you need the network. If you can't get to the server, you can't do anything. But one of the things I'm going to show you is through service workers and web storage, it becomes possible for us to build apps without any network at all. And this is really critical. So network being optional or treating the network as an enhancement is key for a lot of reasons. Whether it's because network is bad, the power goes out, for example, which happened to Evan in the keynote. Or you can't get on the Wi-Fi, or you're on a train and the Wi-Fi or your signal is flaky on your cell phone, you're in the mountains. Or maybe you're just paying high data rates. You're a Canadian who pays high data rates for their phone. Yes, hands are going up. And you don't want to shell out for network activity all the time. Often you may want to run your device without data. So we want to be able to treat the network as an optional thing and only use it when we need it. These websites need to feel like an app. So we're going to see that it's possible to run these web pages, these web apps, without looking like they're in a browser. We don't have to have a URL. We don't have to have a browser around the outside of it. It can just be whatever it is you're working on, which is really important, especially for people to feel like the boundary between what is a native app and what is a web page can be erased. I said that the network is optional, but we also know that we live in a world where data is so critical. And when I say data, I mean real-time updates, whether it's status updates, news, whatever it is, connecting to services. So these are apps which also do what the web does best, which is pull information off of the network. So they are always up to date, and they use a really interesting combination of caching mechanisms in order to make this possible. These apps allow you to re-engage your users. So they do that through push notifications. It's an odd thing to think about a web application running when your phone is like this, and interacting with your lock screen is not the way you think about interacting with the web. But it's the way that a lot of us interact with our apps. Somebody emails you, you get a notification, you have an alarm, and that notification comes up. We can do that with progressive web apps. These are apps that have to be run over secure connections. They have to be run over HTTPS style connections in order to work. So that's part of the security model of it that's baked into it. It's pushing the web toward an HTTPS always approach. Because they're websites, these web apps are discoverable. You need to just use a search engine. They are, after all, links. So you can have search engines index them, which has been a huge problem for much of native apps. How do you get people to deep link into your app? It's a really hard problem. It was a problem with Flash. It's a problem with native apps. And there are workarounds for it, but the web has solved that problem long ago. So we can take advantage of that just using standard ways that web pages work. These apps are shareable in the sense that all you need to get to them is a URL. So if I can email you or text you a URL, you can get onto this too. If you can go to a search engine and find it, you can get on it too. They're making use of the largest web store, if you will, in the world, which is the web itself. So being able to find these things simply because you can go to a link. Also, they're installable. So the hardest place to get any code you write today is right there, is on that home screen. And if you look at, this is I'm using lots of photos from a lot of videos, but this is some random person. If I asked you to show me your home screen, which I won't do, but what's on it? Probably Facebook, Twitter, an email client, I don't know, Instagram. You're using social media, you're using the hits. You've got top 40 apps on your phone. We all do. We all use those things. But maybe somewhere up here in a folder called Other or something like that, you have that long tail of things that you are interested in as well. Schedule for a conference or something that's timely for what you're doing right now. Being able to take a web app and put it on your home screen for something that you want to interact with over and over again is really important. We can do that. So these apps begin life as a link, as a URL inside of a browser tab. But you can promote them. They can progress to become an app on your home screen. That's the idea. So let me take you through, that's the concept of it. Let me take you through some of the tech that makes it possible. This is one of the first one, which is, has been part of the web for quite a while, but it has been extended. So if you haven't been keeping pace with modern trends in web development, web workers have become more and more important. And essentially, a web worker is a background thread that you can use. There's a series of different types of web workers. Web workers, shared workers, and now this thing called service workers. They have similar things in mind, which is that I should be able to write code, JavaScript code, which runs off of the UI thread. So the main thread that the user is interacting with, I can have another thread that's doing things like talking to a database, which is communicating with WebSockets to other players in a game, which is generating passwords or hashing files or whatever it is. But it's doing some complex task on a background thread so that you don't lock up the main thread. The big difference here in what's new and what has unlocked what we're talking about here is this concept of a service worker. So I've stolen a couple of diagrams from the people at Google who built this, but the concept is this. Imagine you write a script, and typically with a web worker or with any JavaScript, when the page closes or you close that tab, the code stops. But that's not the case with a service worker. So a service worker gets installed, as it were. It can run in the background. It runs separately to the page that you're working on right now. And even more importantly, the service worker is allowed to step in between your web page and the network. So you have a piece of code which can handle requests and response. Essentially what you have is you have a web server. You have a web server built into your browser for that domain. So if a page needs to request something, it can ask for a URL, and this service worker can make a decision. It can either go to the network and get it, or it can go to a cache that it manages and then service you with one of those two things. There's various ways that this gets used. So here's a slightly different scenario. In this scenario, you have a page which goes to the service worker. It asks, let's say it asks for a CSS page. So your app uses CSS. You ask for the CSS. It goes to the service worker, and the service worker says, I'm going to go to the cache, and I'm going to request it. And I'm going to use it out of my cache here, but I'm also going to go to the network at the exact same time, and I'm going to refresh my copy that's in the cache so it stays up to date. That's one strategy you could use. Other times you might want to use the network first and then fall back to the cache if it fails. Or you might say, I'm going to go to the cache and the network at the same time. Whichever one's faster, I'm going to use that. There's a whole bunch of different strategies you can use as a programmer to decide how this works. But essentially what you can do is you can control the routing and the caching of all the things that get shown here. Essentially, if you've been doing web development at all, you've been doing this. You had a server running in PHP or Python or whatever it was, and you had everything else in a web page. Now you can collapse all of that, and you can do it in here. So it's a really different model. This thing runs even when the page isn't there. So if the user asks for the page itself. They open up the browser and they ask for a page. It'll go here to get it if it has it. Very, very powerful. Another thing that has changed that allows us to do this, again, these are standards that have existed for a while and we're just taking advantage of them, is web storage. So a whole different levels of storage, local storage, session storage, and then these last two are really important. One called IndexedDB and one called cache storage. I think it's not well known to a lot of people that you can store hundreds of megabytes of data for a web page inside the browser. So it can be anything you want. It's not, we used to think about cookies, and you're going to store little bits of information, but I might want to store hundreds of megabytes of images. I might want to store data. I might want to duplicate a database that's on a server for offline access. I mean, I can do all of those things using IndexedDB. So IndexedDB is a key value storage mechanism that's associated with the domain. The caching storage allows me to take requests and response. So it's essentially I can use URL based, instead of a key value pair, I use URLs and responses to cache things, and I can work with those. Again, I don't want to go into too much of the depths of the tech, but using that concept, what I can do is I can re-architect how I build a web page or a web app. I can build using a model that looks like this. I have an application shell, and then I have content that runs inside that shell. So imagine you're building something like Instagram or Twitter or whatever it is. They follow a similar pattern. You have an app. The app has a menu that you have to work with. It has icons. It has images. It has scripts. You have essentially what you need if you want to boot your app, the most basic concept of your app running. That's the app shell. This thing here, we put in the service worker. We cache it so that it's available even when there isn't a connection to the web. Then everything else that you see in here, text, images, and so on, think about how we would do this. Even back to the days of ASP or PHP or whatever you would do, you would tend to do a database and then templated HTML. And you would do a query to the database, you would get the data, and then you would produce HTML that looks like whatever it is the data you have there. Here we're doing the same thing. We put this data into an IndexedDB data storage that's attached to the web page in the browser. And then we can generate web pages out of that. So we can do that with a combination of the caching, storage, IndexedDB, and service workers. So we separate out the data of an app from the shell, or this thing that you would boot. Another thing that's possible now is the fact that push notifications have made it into the web. So that I can re-engage you, and you may look at this as an annoying thing. How many web pages have you been to that say, you know, random web page would like to send you notifications, and your first thing is, no, don't allow this, no, I don't want that. But maybe you do want that. Maybe this app is useful enough to you that you're going to allow it to happen. In the App Store model, we just install that thing blindly. Sure, it shows you a big long list of things that you're agreeing to, you're like, whatever, install. I want all of it. And every app, even some stupid game, has a notification that pops up and you have to go in and turn that thing off. It's not that different here. So re-engaging users with no browser tab required. Again, we take advantage of the service worker. So if a server sends a push message to a mobile device, the operating system gets it and it routes it to the browser. The browser wakes up your service worker and allows your service worker to decide what to do. So again, you have a hunk of JavaScript code that's running. There's no browser showing. There's no web page. The service worker can show a notification to the user, so on their lock screen, for example, with actions. Delete this email. Yes, I want to go and look at this update or whatever it is. The service worker can also use that time to go to the network and download whatever it needs to in the cache. So if somebody has sent you a new message, you want to go and download that message and bring that in. We can we can do that so that when they click on the notification, the content is fresh. It's the most recent thing that we're looking at. The last thing I'm going to mention here is the fact that we have a standard now for how to specify metadata about a web app, and it's called manifest.json. It lets us include it in the head of our our web page, and we can say, here's a link to a manifest.json file, and it looks like this. You can specify things like the name of the app. You can specify icons at different sizes. You can specify a URL to show when the app starts, etc. So all of the metadata that describes how this app should function is in here. And you can also do things like this. You can see this is the same web app running in 2 different ways. Here it's being run in a browser, and here it's being run standalone. So there's no URL, right? It has just faded into it. You can even do things like you can control the background color and the theme color so that your app merges with the operating system colors if you want, or it looks like it's a native app. It feels like it's part, like you clicked on something and it's running and it's part of the OS. Okay, examples. So let me show you a whole bunch of examples. Let's see if I can get my... And if you've got a phone, I know you didn't want to download the Subway app, but come on, you can go to these URLs. So try these URLs out as we're talking. So the first one is pokedex.org. And you see, I've got it running here, and I've got my dev tools open because I want to show you a couple of things. So I'm not a Pokemon player, so I'm not even going to pretend to know what this is, but this is all data on various Pokemon characters and how they evolve, and I don't know. But it's a very, very cool app for purposes of what I want to show you in terms of how it runs. So what is this thing? Well, it is, first of all, it doesn't look like a web page, does it? I can search in here and find items, look into them. There's no URL. It feels like I'm in an app. And it's because I am in an app. So I'm in an app that's built out of web technologies. So the main web page, here you can see how these things are being loaded. And it's probably hard from where you're sitting, but it tells me here who initiated this. So the index.html page that's running came from service worker. So did main.js, and on down. So things are coming out of cache or from the service worker. Let's see if I can do this. If I turn off my Wi-Fi and reload this, I've switched networks. Give me 1 second to put it back up. So this is an impossible thing of the web when I grew up. Like the idea that you would be able to completely work with an app when you have zero network. But here I can do that because all of these things are being programmatically used out of service workers and caches and so on. I'll go back to my slides here for a second. So this app is really interesting. It's built by a guy named Nolan Lawson, and he did it as an experiment almost, or as a demonstration app, and it's perfect for that because of the number of things that it shows off. So all of the shell of the app that you're seeing is being served out of the service worker. It's cached in the service worker, as I showed you. All of the content, like all of those characters, their attributes, all of the things about them, are inside IndexedDB. And he's using web workers to render the UI. So he is generating the visuals for this on a background thread and then sending off changes, diff changes back to the main thread, which is why it's so smooth. Like if you're playing with it on your phone, it really feels good. Like 60 frames a second is pretty easy for this thing to achieve because it does most of its work on a background worker thread. And it uses all of the I/O for the databases done on a background worker thread. This is the architecture of what I'm talking about. So he's using a web worker and a virtual DOM. In other words, he has he's constructed inside the worker the same DOM that is out here, but he does all of his operations on this, and then he sends a patch, or he does a diff and a patch to tell what to apply to the main thread. So it runs really smoothly. This is another one that I'm not going to do a demo of now, but if you want to play with it, Google just put this one out, and it's kind of a fun thing. It lets you throw and catch paper airplanes of people around the world. It's got lots of music and so on in it, so I'm not going to show it to you right now, but it's an interesting one. This one here, Flipkart.com. So this is one of India's largest e-commerce sites. And in 2015, they shut down their website and they moved to mobile apps. They said, we're not going to do Taco Bell did the same thing. Lots of people have said this. We're going to shut down our website and we're only going to do native apps because people want native apps. But that didn't work because people didn't want to install their app. So they found that 63% of their users reached the site on 2G networks. They're on slow devices, slow networks. And so caching was really important. And they found that once they moved to a progressive web app and people could add this thing to their home screen, so this is what it looks like when you want to try and add one of these apps to your home screen, that they had a 60% of all Flipkart users now come from people launching this progressive web app from their home screen. So it's a really interesting thing because they haven't gotten rid of their native apps. You have a hybrid approach where people can try out Flipkart. I have it running over here. Let me get it. Here's Flipkart. People can try this out. And again, it feels just like an app, or if you wanted to download, I think this one doesn't show a link for it, but being able to install a native app or a shop here, like this thing is just, it's a great experience for using an e-commerce site. And again, you can play with it. But the fact that you can play with it without installing it, like I'm an Amazon user, but it took me a long time to install the Amazon app, for example. I tend to think about going through the website. Why is that? I don't want to put the Amazon icon on my home screen. Like it's not important enough to me on a daily basis for it to be there. But a URL like this is something that I could decide over time. You know what? I am using this all the time. I'm gonna promote this up to my desktop. And it's not a big deal to do that. This is an example of push notification. So imagine you've registered for some product that you're interested in and the price goes down. And that web app can come back to you and say, well, there's been a price drop in this item you were interested in. Click here to go and look at it and purchase it now. So this is something that's happening on the lock screen. There's no browser. The person's not running the app, right? So it's a way to re-engage. Here's another one. This is housing.com. So another one from India, so a leading real estate site in India. And they built this progressive web app and they saw a 38% increase in conversions. So they already had iOS and Android apps built, but they found that people weren't installing them because they had limited storage on their devices. So people were mostly using them on low-end devices, and they couldn't justify saving all of that content onto their device, and so they just wouldn't install it. Which I'm not that much different, and I have lots of space on my device. But for whatever reason, I don't know why, but we tend to guard that space. You want to put music there, you want to put movies there, you want to do other things. So they did a progressive web app, and again, it feels like an app. It is an app, but they found that people came to it. So people could try the app without installing it, and it made it frictionless for people to get engaged with it. So this thing I have running here. And if you're looking for property in Mumbai, it's good. My network is flagging, but it's an interesting one. Explore homes. It's just an interesting site to go and look at again for how well built it is as an app, and it works like a native app, like you would expect from a native app. WashingtonPost.com. They took the paper, and first of all, they found that 70% of all traffic to the Post site is coming from mobile devices, which as a newspaper, that's pretty huge, right? So they're not coming from their desktop, they're coming from their phone, they're on their commute in or whatever, that's what they're doing. 63% of users, so 70% are on a phone, 63% of those are using it from the web, and 7% from their native apps. Can you imagine justifying the cost of building a native app for your platform for only 7% of your users? Sometimes I think you could. Sometimes it's important enough to do it. And it definitely is if you're in the top 40. If you're Facebook or your Instagram, then building a native app makes a lot of sense. But if you're building something that people engage with in light ways, it's a pretty hard sell. So they switched over to this progressive web app, and they've had really good success with it. And again, I have it running over here. My laptop is full. It's really well done. Like it, again, feels like an app. And it's the Washington Post as an app. Installable to your home screen, available to do offline access, available to do push notifications if that's something that you want, etc. So I wanted to end with this, with a story, which I thought, as I was researching this, one of the things that came across Twitter was a terrible story about a developer who wrote the Dash iOS app. So I want to talk to you about this concept of permission. And I think one of the things that's most important about the web, as opposed to app stores, is the fact that to be on an app store, to write any code, to publish any code, you need permission. You need permission from the App Store to make an update, to have a color change, to use an icon, to do absolutely everything. And increasingly, the permission isn't even from a person. It's an automated system that you can't interact with, you can't talk to it. So it's a really weird place. I mean, here we are talking about open source, and there was a time when we would have talked about open source as desktop software and software you install as a user. But as a user installing apps, it's very, very difficult to think in those terms now. You are gated in terms of what you would do as a developer. So here's a story of this developer. Let me pull up this website and show you. So this guy has a popular app, the Dash app. It's essentially a documentation browser used by a lot of developers and so on, and it was very popular on desktop but also on mobile. And one day he woke up and it was his account had been blocked for no reason given. But it was a popular enough app that he blogged about it and people blogged about it, and Apple had to respond to it. And they went back and forth trying to figure out a reason, and they eventually accused him of of fixing reviews, like interfering with reviews of the app in the iOS store. And they did more research, and he realized that at one point he had used his credit card to help a family member get their Apple system set up, and Apple had somehow linked those two accounts. And so for whatever reason, in Apple's mind, whatever had happened with this other account many years hence came to influence what was happening with his account. So Apple shut it down. This app that people had paid for, that he has on the iOS store, is just gone. There's nothing he can do. So he has to find another channel. There is no other channel on an iOS device currently to do this except the web. I think that one of the most important things about the potential for doing apps and using the web is that the web is a permissionless platform. I don't need to have Google or Apple or whoever it is let me into their store. I just need to put something up that's reachable through a URL. So he can continue on and build his stuff using the web. But the App Store thing, he shut down in terms of the App Store. I think that's a terrible model for us. And I think as we think about open source and we think about access, really keeping your eye on what's possible with web apps, because I think web apps put a crack into those platform giants, like in terms of allowing you to get your stuff in there. Anyway, I really want to talk to you about innovation on phones and so on, so I thank you for letting me tell you about progressive web apps. And a lot of this stuff is very, very new. You may even be using some of it without knowing it, because people are slowly rolling out bits and pieces of it. But if you're building any kind of web tech, I would encourage you to look at it. Look at service workers, look at the caching APIs, look at the storage APIs, because they let you just do things you could not dream of when we first started building things for the web. Anyway, thanks very much. That's it.
I have a couple of questions. So it's quite promising for this kind of trend, like methodology you talked about. But I would just like to understand what's the difference between progressive web apps and Ionic project-based apps or something.
So Ionic is great. I mentioned at the beginning, there's been various attempts to use web technologies, essentially build things with web technologies and then ship them into these native app stores. So technologies like Ionic, what they allow you to do, Adobe has it too. What's Adobe's version of it?
Fedora.
What is it called?
Phone app or Fedora.
Phone gap.
Yeah.
So these are great technologies. I can build using web apps, and they essentially give me an API, and often an extended API, to do things like interact with the contacts, interact with other parts of the phone. And then when I'm done, they package it up as a native app. It's a native app with pieces of it that have web contents that are running inside it, and then you can put that in the web store. So if your goal is to get into the web store, I think that's still a really good target way to do it, because these apps, for example, they aren't going to be in the web store. They're designed to be like something before that, something like a lighter touch way of trying something out. So you may decide to do an Ionic app that's installed into the web store and a progressive web app as a way for people to try it. Because most people who get even to the installation page don't hit install on an app. You'll note that no one here installed the Subway sandwich app today, despite the fact that I told you it exists. So people are hesitant to do it. I think that's one of the big differences. Did you have another one?
Yeah, another question is, could I just use the AngularJS to realize this methodology?
Could you use Angular?
Yeah.
Yes. So people are using React, Angular. This is not, one of the things I like about this is you don't have to commit to a framework or a set of libraries or whatever. What you're doing is you're essentially just using the infrastructure of the browser to deal with network loss and caching as a programmer. But how you build your app is totally up to you. So if you have an investment in Angular and you want to use Angular to do all of this, you absolutely can. And in fact, that's probably a great way to do it, because so much of the app-like way of building that, all the state management, etc., you can use things with service workers as well.
And how about just the access, the way of accessing the hardware resources or APIs provided by the native operating system, like Bluetooth or something else? Is that a limitation of this kind of
Well, so that's part of the progressive aspect of these, progressive enhancement. So for example, Google is, in the latest version of Chrome, they're shipping Web Bluetooth. So it's very new, and iOS doesn't ship it yet. Mozilla hasn't implemented it yet. So you have a lag. So if you really need to gain access to native APIs, then something like Ionic may be a better way to go. There is a reason to use native apps sometimes. Sometimes you want to take advantage of native aspects of the device that you're on. But if you're trying to show homes that are for sale in Mumbai, you don't need access to, typically you don't need access to native aspects of the phone. What you need to do is you need to render an experience to the user that they can interact with. So I think it's going to depend on, if you're building a game that needs to unlock something that's very specific to the device you're on, then native is still the way to go. But if it's not, then this becomes an interesting experiment, way to try and do it.
Thanks.
Yeah, Andrew.
Do they try to make sure that the widgets inside the apps look native, or is that another thing that matters anymore?
They don't. So this was your point about using Angular, or they don't care. Like these technologies just serve CSS, HTML images, but it's up to you to decide what they should look like. So if you want to
Or
have,
do you have the option of, because with Android, every version of every device looks different slightly. So if you want something that looks native, there's a lot of work that has to go just by detecting which version is matching.
yeah,
Does it look like they care about that?
No, they're not. So these are low-level APIs that aren't thinking in those terms. It would still be on you to, like for example, that manifest.json that I showed you. You'd have to have appropriate size and resolution icons for every platform that you're on. And like it's still a mess. You still have to deal with the fragmentation of all these different platforms. But you have a mechanism for doing that. So I can load and cache the assets that I need. If I move from my phone to my tablet, I can download other bits of the app that I now need that I didn't need before because I'm showing other parts of the UI. You know, there are ways to deal with that, but this doesn't address them specifically.
Going back to that example, that gentleman who lost his app on the App Store, and he moved to a web app. But now,
He didn't move to a web app.
Oh, really? He didn't? Oh.
I'm not, he did not do anything with the technologies I'm talking about here. He invested heavily in iOS and Mac and so on, and he got bitten by it. Now I'm not trying to, I mean, I'm here on an Apple laptop. I love Apple hardware. I mean, I also have my Google phone, so it's the best of both worlds, right? But I'm not telling you shouldn't use Apple, but I'm saying that there is a cost to the permission model of these app stores, right? Like you're at the mercy.
I'm just saying that before he was making money. Now he's not.
Well, again, these things exist. So the web payment API, for example, is something that's just landed in both in Android and iOS. You know, from your phone, being able to pay for things like that actually exists.
People have a perception that apps, like I'll pay for an app. You know, people will say, yeah, I'll pay you $1 to $5. But how does that compare with like paywalls on websites? People pay for.
I mean, I think the things that you're talking about are beyond the technology. Like, it's a really interesting question, but I don't think these technologies have anything to say about it. I could charge for these, or I could not charge for them. Like the Washington Post could close it down and make it harder to access it. You could sell the app, you could sell a subscription. There's a lot of different models you could go for. But if you look at most of the apps on your home screen, did you pay for them? Like in here. You didn't pay for them directly. You're paying Google and Facebook with your data. Like you're the product, but the apps are free, right? So I don't know. Anyway, I should probably not stand in the way of human lunch. So it's 5 to. Thanks very much.